Right, so here we have a diagram that shows the graph of the velocity in feet per second for a particle moving along the line x equals 4. And so the questions that we need to figure out are, during which time intervals is the particle moving upward, when is it moving downward, and when is it at rest? And then we have to find the acceleration of the particle at these values of time. So when t is 0.75 seconds and when t equals 4.2 seconds. Okay, so this problem, is going to deal with, is dealing with kinematics. So that meaning like the physics of like motion. So when you start these, I always just recommend that you just write somewhere like a note like that you're dealing with, position, velocity, and acceleration, and then keep that in the back of your head when you're working through these. And usually for position, we'll represent it with S of t. Velocity will usually be V of t, and acceleration will be A of t. And the way they're related, which you, again, make sure you know this, the derivative of S of t, the derivative of position, is velocity. So S prime of t is velocity. And then the derivative of velocity, so V prime of t is acceleration. So I usually would just recommend just writing that, to the side somewhere whenever you're dealing with a problem like this, just in case you can refer to them easier. All right, and let's go to this problem now. So this shows the velocity of the particle. So if we want to figure out when it's moving upward, a common thing is for students to see that like, oh, like the velocity is basically like how this graph is trending, like oh, the particle's moving down because the graph here has a slope that's negative, but that's not the case. Remember, velocity tells you the speed and direction of a particle, speed and direction. So as long as the velocity is positive, so when velocity is positive, that means that the particle will be moving upward. When it's negative, the particle is moving downward. So that's all we care. We don't care about the value or the way the slope of the line is. So this region here, the velocity is positive. On this region, the velocity is 0. And now from this region, the velocity is negative. Negative here, negative here. And then from this part, the velocity again is positive. So it's moving upward whenever the velocity is positive. So the velocity is positive from time t is equals 0 to 1 second. So it's moving upward from 0 to 1. And then the velocity, it becomes actually still. It's at rest here because the velocity is 0. So it's at rest. So let's go to this one. It's at rest from 1 to 2 seconds. So when t is 1 to 2. It's not at rest here. Don't get that confused. It's only at rest here because the velocity is 0. So let me put that it's at rest when velocity, let me put V of t equals 0. There. It's moving upward when V of t is greater than 0. And it's moving downward when V of t is less than 0. So V of t is less than 0 or negative from 2 to 3 all the way up to here. So from 2 to and now to figure out what that value is, let's calculate the slope of this line. Remember, the slope of this line is, it's going up from -2 to 3. So the slope is 5 over 1. So the slope is 5. So that means that for these 2 units, it's going up by 0.4. Because basically the slope is 1/5. So 0.2 for every unit. So this value here will be 4.4. So that's 4.4 comma 0. So the particle moving downward from 1 to 4.4. Or sorry, from 2 to 4.4 is what I meant to say, because this is when it's at rest. So from 2 to 4.4. And now let's look at acceleration. So now the acceleration of the particle at these times. So remember, acceleration is the derivative of velocity. Acceleration equals v prime of t. So if we have the graph of velocity, the way we interpret acceleration is by calculating the slope of the line. The slope of this line, at every point, tells you the value of acceleration at those points. So we want to look at the slope. What's the slope at t equals 0.75? So 0.75, it's going to be somewhere in here between 0 and 1. And the slope along this whole line, it's constant since it's a straight line. So the slope, goes down 2 and over 1. So the slope is -2 over 1, or -2 feet per second squared, since we're dealing with acceleration. And now we want to look at what's the slope at 4.2. So 4.2 will be over here. And all along this line, which, we just went over that in the previous part. All along this line, the slope is 5. So the particle is accelerating at 5 feet per second squared from here to here. 5 feet per second squared. And that's it.